venture, I can't stand Anthony. I was like, no more good leader for you. You're such a bad job. He did horrible. So yeah, there we go. Okay, so we're going to talk about introduction to calculus, and the calculus is start with a long time ago. Okay, let's start with limits. Before calculus, there was a pre-calculus, right? Pre-calculus. Matter of fact, there was going to be AP pre-calculus by next year, which is kind of weird.
I would have loved that. What do you mean
what's the
AP
point?
pre-calculus?
Pre-cal's supposed to be very pre-calculus.
Okay, yeah, I don't know. Okay, so pre-calculus is gonna we start with algebras. So algebra. We study trig, and we even study like polar and matrix C if we get there. Usually it's not matrix. And last thing we learn is limits usually, right? And limits gonna get to, from limit is gonna get to a stepping stone to go to calculus. So why limit? And a lot of you guys says, what is a limit, right? So if you take Chaparral's class, do you remember what is limits about? Let me hold my breath.
Like,
Let's not kill him.
the limitations in the function that limit.
No, we got someone over there.
Is it like the chance like of a graph? You did it. I don't think.
Isn't it like as x approaches like a certain value, what the y value is?
Okay, yeah. Pretty close. I didn't want to keep on holding my. I don't want to die here. It'd be a funny way to die. Yeah. So so I hate silent class. I just hate like when I ask a question, everybody's like just silent. So yeah, when you approach some value and there's some type of output, right? There's some type of output. I'm gonna show you an example that the limit it does happen, and we're gonna show you two examples. The first example of limits is actually it's not a proper limit. It's actually just limit. It's called one-side limit. Usually you don't do one side. Usually do both sides. We're gonna talk about that and also. So limit is assume that you can get there. Assume. We can talk about why that assume. Assume you can get to that value, and we're gonna approach very, very slowly, right? Very, very slowly. And I'm gonna give you one example, right? So we start with something in algebra 1. Teacher is gonna tell you anything to the 0 power is what? 1. But do you understand why? Teachers just told you memorize it, and you are just memorizing. So the problem with that is student only learn to memorize without understanding, and that is the biggest problem in math education right now. You memorize something and you forget everything in the summer, and you do it all over again every year. That's pretty much what happened. And that's sad because everybody should understand why anything to the 0 power is 1. Does anybody know why anything to the 0 power is 1? Pick a number between 2 to 5. 3. Okay, that says 3 to the 3rd power is equal to 3 times 3 times 3 equal to 27. 3 to the 4th power is 3 times 3 times 3 times 3 is equal to 81. 3 to the 2nd power is 3 times 3 is equal to 9. 3 to the 1st power is 3. Now, let's look at a pattern. The next thing is going to be obviously 3 to the 0 power, right? Now, what's the pattern from 81 to 27?
You get rid of it.
You divide it by 3. Not get rid of it, you divide, right? You divide it by 3, and you divide it by 3. And then, obviously, you divide it by 3, that becomes 1. That also answers the next question, next exponent rule. y is -1 is 1 over 3 because you divided by 3. So that explains 2 rules about exponents. And students should learn this at very beginning. But the problem is the teacher will tell you just memorize it because they don't know. Okay, so you gotta start learning the basics first, and those are the basic occur. Now the next question, so it doesn't matter if it's 3 or 4 or 5 because you divide that same number each time. Eventually any number is always gonna be exactly 1. Even 1.2, like 1.2 to the second power, 1.2 to the first power, 1.2 to the 0 power is always going to go to 0. Does that make sense? Oh, not going to 1, sorry. Does that make sense? Now, your next question should ask me, says, what will be your next question? If this is true, anything to the 0 power 1, what will be your next question? What if? What kind of question would you ask? Tony? No, that's not what I'm trying to get to. Yes, Jorge?
How 0 is 0 power 1?
Exactly. How is 0 to the 0 power 1, right? Because it doesn't make sense, right? If you look at 0 to the 0 power, question mark, right? If I have 0 to the 4 power, 0 times 0 times 0 times 0, 0 to the third power, 0 times 0 times 0, 0 to the second power, 0 times 0, 0 to the first power, 0, 0 to the 0 power is 1, question mark. How does that hell work? No, right? So what we're going to do is we're going to use a limits approach. Like Matt was saying, approach a number slowly. And we're going to show you how this actually works in terms of limits. So what we're going to do is we're going to start with a 1 to the first power. What's 1 to the first power? 1. I need you to get your phone out. I need you to use the calculator button. So try this, which is kind of interesting. We're going to approach by small increment of 0.1. So I'm going to go down 0.1 each time until you get to the 0 to the 0 power. But if you type in 0 to the 0 power, what does the calculator give it to you? What does your iPhone calculator give it to you? Or what's your normal calculator give it to you? No, if I do 0 to the 0 power in the calculator, what would you get?
Error.
You're going to get error, right? So it's error or is 1, right? So that's the perception people have to understand. So let's do 0.9 to the 0.9 power. What would you get?
0.995.
Okay, so 0.909. And you're like, oh, okay. Maybe what I learned in the past is wrong because it started going towards 0, right? And we can establish another proof, establish another coordinate. So 0.8 to the 0.8. Now, what do you see with those two numbers? It's going down, right? It may be all your teacher in the past told you a lie, right? Even including myself. How about 0.7 to the 0.7 power?
0.779.
Okay, let's look at this number. Do you see anything that's worth suspicious or anything like that?
It's like decreasing from getting closer to 0.
It's getting closer to 0. Maybe your teacher, Algebra 1 teacher, told you lies, right? Because if it's 0 to the 0 power is 0, then your Algebra 1 teacher told you anything to the 0 power is 1. But nobody bothered to ask. This is my problem about things. Nobody ever questioned the authorities. If you're learning, you should question me. Mr. A, what you say is true or not. My smartest student last year was Ethan Mather. Ethan Mather is never have a good grade in my class. Actually, probably flunked through every single class. But he was the best math student I ever have because he always questioned me. He questioned everything I said. He said, why do you think that's true? And you never question when you're little. You should question. Raise the question is very important. 0.6 to the 0.6 power is what? Do you see anything suspicious? Of all the number that, do you see anything suspicious? Yes.
It's not going down as much.
It's not going down. It's slowly decreasing, right? It's decreasing at a decreasing speed. Does that make sense?
Mhm.
0.5 to the 0.5 power.
0.707.
Okay, good. 0.4 to the 0.4 power.
0.693.
Wow. Do you see that slow down? 0.3 to the 0.3.
0.697. What about that?
Yeah. So pretty interesting. It went back up. How about 0.2 to the 0.2?
0.725.
Go up by a lot. 0.1 to the 0.1?
0.794.
How about we're gonna approach like this, 0.01?
0.955.
And maybe if I put like 80, it's gonna pass 1, right? Because we put 20 already is jumped by like 0.14, right? If I jump it now to 0.14, then I'm gonna pass over 1, right? So let's do 4 zeros. What's that gonna get? 9? How many 9s? 3 9s. And if you put 8 zeros,
1, 2, 3, 4, 5, 6, 7, 8. 0.
0?
No, I did it wrong.
0.99.
How many 9s?
Yes.
7 9s. So you can pretty much safe to assume they go into a 1. And then if you type in far enough digit, they cannot generate anything. They will round it up to 1. And that's what happened. But do you guys know this thing change throughout this whole lifetime? You never seen this, right? And it's very interesting. So don't ever just accept the status quo of what your teacher teach you. That's what I'm saying. You have to question me. Imagine if nobody questioned, people still think that Earth is the center of the universe, right? So there are people like Galileo, like Kepler's. They question and they change. Long as you don't say the Earth is flat, then it's okay. But as it's like, really, Earth's not flat? Well, they have pretty interesting argument though if you listen to them. So yes, so those are the things that you should question. I'm trying to tell you, you should always question. Today, if you learn nothing, you should always question everything in order to be the highest level of a student or surpass your teachers. And I want you to do that. I want you to surpass your teachers. I want you to be smarter than me within 1 year. Luke Davis is another one. I says, in 1 year, you're going to be smarter than me. I cannot educate you anymore. You already know more stuff than I do. And he's only a sophomore, right? So that's what I want you to do. I want you to be like this. So question your teachers. That's not a bad thing. Okay, it's not a bad thing. So question me, please. If anything in doubt, question. Because I can tell you why and why not. If I cannot tell you, I will find out why is it, how it works. And Ethan Mazur did that. Okay, so the next thing I want to talk about is, well, why does that matter? Which function that represents this situation? If I will write this in terms of function, which function will represent, let's say y equal to what function equal to the situation? X power x. Good. Very good, Tony. So x to the power x, because you plug in 1 is 1 to the 1 power, 0.9 to the 0.9 power. If you graph it, right? If you graph it, that x to the x power look like this. It has turnaround point at 0.369. There's actually a specific value there. Why do they turn around? Let's require calculus to find it. Actually require very high level calculus. Not people get a BC, not people get an AB who got a 5 can find it. People like Sheila can find it. Why, where to turn around. But people like Samuel Duff, he won't be able to find it because he'll be like, I don't understand. But they're only like a certain tier of student can find where do they turn around. Okay. But that's that. Now this is limit, approaching something slowly, right? Now that's a one side limit. Okay, that's one side limit. So imagine that two side limit, you're gonna do the same thing. So I said Deborah Edison. Deborah and what last name is Stump, right? That's, okay. So we're gonna say Deborah has. I says I want you to go investigate. There was a black hole at this place right here. There was a black hole at. We just talk about this x-axis. Let's just say there is a black hole right here. Okay. And it's a value of 8. Okay. So what I want you to do is I want you to find out, is that value at 8? Is what happened is I'm going to ask Deborah to stand right here. And I'm going to ask you to, Edison to stand right here. And I'm going to ask you to take a GPS and go detect where's the small tiny black hole. Ideally is you don't want to stand on top of black hole because you'll die. And there was like, I think 8 different ways to die or 6 different ways to die on a black hole. You become spaghetti because the gravity is so large. It's going to rip you to pieces in atoms because the gravity is so large. So what you're going to do is you're not going to be stuck on a black hole. What you're going to do is you're going to approach one step and one step here. And you approach another step, you approach another step. And you say, hey, I'm not dying yet. Good, right? And if I approach here, if I approach here, right? And slowly go in from both directions. So this is called limit. Limit should approach from both sides. And like last time, is approaching from one side, this approaching from both sides. Now, so for me, I'm going to take a 1 micro step now because I don't want to die. I only go halfway. So we know it's probably between 7.5 to 8.5. And if we take another half steps, where we know is 7.75 to 8.25. And maybe eventually you get close to 7.99 and 8.001. And eventually we can say, well, that's safe to assume before we're going to die, we're going to stop right there. We're going to say the coordinate of this black hole is at x value of 8. And that's how limit is. Why did I say assume? Assume you can get there. Let's assume that you can stand on top of A. But we're not going to get on top of A. We're going to get so close to A, but we're not touching it. It's like you and your sister fight. You put a finger across their forehead and say, I'm not touching you, I'm not touching you, I'm not touching you. It's kind of like the same situation. I don't know. Do you guys ever get in this fight before?
Mhm.
You did? You have a sister?
No, I have a brother.
Oh, he does that?
Yeah.
Oh, okay. How old is he?
A lot older than me, so I don't understand why he won't leave me alone.
Really? He did that to you?
Yeah.
Even though he's older than
he'd be like, not touching you. And then he would like he's kind of abusive, to be honest.
That's what you do. Older brother's supposed to do that, right? So that's the idea. Now we're gonna use this idea to do the first problem. So there was calculus. So we says there was a pre-calculus. There was a limits. Limits introduction of the calculus. Now Using limits, we're gonna go to calculus. Not AP calculus. AP calculus is a joke. But calculus, the actual calculus. Now you have to know which two person invent calculus. Which person invent calculus? Newton, yes. Isaac Newton, very well known. There's one more person you need to know as well. Nobody ever know that. You start with the L. Yes, no. Leibniz, a German mathematician, I think. Very unknown, but have equal amount of contribution as Newton. Equal amount of contribution. So Leibniz, it's actually a lot of notation is actually from Leibniz. Something like implicit derivative is actually from Leibniz. Very, very important person. Nobody give him the credit though. Right? So Isaac has got all the credit. The funny thing, there was like nobody before that. But if you talk about a lot of mathematicians who gets credit, for example, Pascal triangle, it's actually not a person should get credit. There's a Chinese person before 200 years ago. His name is Yang Wei. Yang Wei is already know Pascal triangle. And before Yang Wei, the Syrian actually knows about Pascal triangle 500 years before that. So 700 years before Pascal, they already know about Pascal triangle. Pascal get the credit? I don't know. Maybe he's white. I don't know. I don't. So that is the situation for us mathematician. I'm just kidding about white. So now you're gonna say, well, what's it got to do with calculus? So Newton have a question. Newton have a question. His question is how fast? I don't know which planet he was interested in. I remember sometimes maybe Jupiter or Saturn. You want to find out how fast Jupiter is moving. You want to find out the velocity of that planet. And supposedly, according to myth, he trying to find. He's a very religious man. He's trying to find the gate to go to heaven. And he thought somewhere on a space because heaven should be somewhere in space. And he want to find out the location of that, the secret gate that he can go in. So he need to find out how fast something is moving. He look at telescope every day. He can analyze the Saturn is moving, and then but he trying to find out what's the actual speed. Well, first of all, he doesn't know the distance from here to the thing. So there's a lot of questions about, and those are the calculation way beyond my head, which is some of you guys will be smarter to tell me 10 years later, or 5 years later, or a couple years later. I have a girl went to MIT, want to be astrophysicist. And she can probably teach me right now. So Leibniz Newton then create two problems. That's two well-known problems. Well, the first problem is called tangent line problem. So tangent line problem. And the second problem is called area under the curve problem. We're not going to get to that. So there are two problems, and this two problem raise to become the idea of calculus. What is a tangent line problem? Well, first of all, what is a tangent line? Does you guys know what a tangent line is? Yes. Touch a point of curve. Okay. When in geometry, what do you learn about tangent line? Could be. Do you guys also hear something called secant line? Have you guys heard of secant line before? What is secant line about?
Doesn't it go through the circle?
Huh?
It goes through the circle.
It goes through the circle. A secant line is a line that intersects 2 points on a circle. So this is a secant line. Yes. So this is a secant. And what is tangent line? Yes.
Can I like draw it? Cause I don't know.
Sure, you can. I don't think you can draw it, but you can tell me how to draw.
It would be like right here, like touching like the.
Just touches one point.
It just touched
Yeah.
one single point. So this point. So I'm going to use that as red because that's a point of interest. And only touch exactly 1 point. Okay, only touch exactly 1 point. So that's called secant. No, that's called tangent, sorry. This one's called tangent. And that's called secant. And the best way to think about it is I have a hot sauce here. I don't know why. I'm going to use this example. This is going to be a tangent line. Oh, no. There's a magnet on the top, that's why. So this is going to be tangent line because it only intersect 1 point. Does that make sense? Now, if you go through it, this, imagine this is a function. The circle is a function. If you go through 2 points, it's called a secant line. But we're going to start with a secant line to get to there. So that's the things that we're going to do. So we introduce two concepts. One is a secant line. One is tangent line. I used to have a water bottle, and I'll explain to the student what is secant line. I'll take a sharp pencil and just stab through the water bottle. And to show you the point is actually go through the functions. Okay, so that will, and that cause like water everywhere. And I don't want to do that again. But it's actually put a big imprint on people's head. So secant and tangent. There's an area under the curve. Well, not any type of curve. It's some type of curve. So curve's like, okay, what is the area between A and B? What is this area here? But there's no geometric formula to find out the area. So how do you find the area? So there's two problems occur. I'm going to show you what is the first problem. The first problem is going to be, for example, you can find slope of a straight line. So slope of this straight line is very easy to find. So what is slope of this line? It's 1/2, good. So slope is 1/2. And you say, yeah, that's 1/2, easy. I can do this all day long. Calculus is easy, yes. But the problem is not that easy. The problem says, hey, remember, what if I have a parabola like this? What if I want to find slope at this particular point? This tangent line right here. And it's constantly changing.
Are you okay, chemistry?
Yeah, I'm dying. Okay, slope is constantly changing, right? Slope is changing, starting going up higher and higher. And it's constantly changing because of different points, because there was different price overrun over there. Do you guys see that or no? Okay. So we're going to create a situation. And this situation is going to, are we okay here? We're going to create a situation for you. This situation is that we're going to have some type of problem. Sorry, I'm going to use black here. I'm going to have some type of parabola here. And this parabola is going to be something like, I don't know, something like this point. And it's like this. Oh, that looks really good, actually. Oops, I just changed it. So obviously we says I want to find slope of this red dot right here. So this is a slope of tangent. So this is a tangent line. So we're trying to find the tangent slope at this particular point. At this point, we're going to say this point is 8.2 or whatever, right? But it doesn't matter. This is a random point. Then I'm going to go with, we're going to name this point. We're going to call this function as f of x. I know it's really confusing, so in a second, I will show you how they work. So this point is going to be f of x. So we're going to name this point. This point has a coordinate. Can you tell me this coordinate is? Well, it's roughly a2, but I don't want to name it a2 because it can be any function. If it's any function, how would I name this coordinate? Thank you. xy. Good. Just some type of x. And y, I'm going to use as f of x. Is that okay? Because f of x is the y value. Are we okay here? Okay, so what we're going to do is we're going to interest about the next point, the blue point, which is the secant line. So obviously I have some type of increase from x to the blue point. How much x value have changed? Roughly 5 units. But we say we don't know. So we say this is an x, and the distance here from here is going to be called h. Okay, so what will be a new coordinate here? New thing here. What will be this called? X plus h. Good. It's not that hard. It's x plus h. If 3 is a h, then just going to be x plus 3. If 5 is a h in this case, it's going to be x plus 5. So what will be the blue point here? What are the coordinate of this blue point?
We have to do the same thing for f of x.
Exactly, because you plug in x plus h. So we have new coordinate from this point to the other point. Yes.
But h doesn't have to be the same value. Right?
H could be arbitrary value. H is some type of random value that you don't know about. Okay, so h is some type of value. So arbitrary. Calculus love arbitrary numbers. It's just some random number that you can think of. Could be 5, could be 2, could be 3. It doesn't matter. Because all that matters is there's new coordinate. So obviously it's going to create this point, this secant line here from this point to this point. Right? There's a secant line here that go into those 2 points. Now, what I'm going to tell you is this. If we go to 2 points, that it has a slope. And I'm going to call it a secant slope here. And the slope is going to be y2 minus y1 over x2 minus x1. Okay, so y2 is going to be f of x plus h minus f of x over x plus h minus x. Does that make sense? I just plug in those 2 coordinates, and those 2 coordinates are arbitrary. And that's equal to fx plus h minus f of x. X cancel out, that's going to be h. So that becomes slope of the secant. That's not a tangent. Now you see this h is 5 units. 1, 2, 3, 4, 5, if you count the grids. What if I can do, give me a second. What if I have a tangent line here? Oh, let me finish this part up. If you need a pass, I'll write you a pass. Tangent. Tangent is decreasing, so I'm going to take this h, I'm going to decrease this point slowly, and I'm going to construct this point here. I'm going to the next point, I'm going to construct a different points here. I'm going to go to this point, I'm going to construct different point here. I'm eventually going to be like this, and eventually like this. How do I do that? I'm going to do limits as h slowly decrease to 0. And that becomes a slope of tangent. So it started slowly, one step, getting closer and closer and closer and closer. Eventually get to 0. That's where the slope of the tangent that we are most interested in. This is actually the first idea of a derivative. Okay? And that's going to be the first thing that you do. All right, so if you don't understand, it's okay. This is just an introduction. It's not a big deal. If you need to take a picture, this is probably a better picture here.
Or just because I can't come back later today.
Do you have lunch? You can come back at lunch. I haven't started grading the second period yet.
Oh, okay, yeah. What lunch do you have, Michigan? Oh, yeah.
I have B lunch,
Oh,
but you can
yeah.
come at 8, doesn't matter.